Good morning, my dear students, and welcome to this lecture series by AKTO. I am Dr. Supriya Furlalpam, Assistant Professor in BBD ITM. I will be taking Unit 5 of KCE 603 Environmental Engineering for you. This is my second lecture. In the first lecture, we have talked about about wastewater treatment systems and the preliminary treatment of wastewater treatment plants. Today, I will be talking about the primary treatment. Uh, as we have already we have talked about this syllabus before. So, we have done this and this. We are going to talk about primary sedimentation now, primary treatment now. So, this is the references environmental engineering by PV and Rowe and environmental engineering by Eskegar references. So, when we talked about primary treatment, we are mainly talking about the sedimentation tank. So, primary treatment where sedimentation tank, we may have others also like secondary sedimentation tank, but for the time being we let us talk about primary sedimentation tank. So, when we talked about primary treatment, we are talking about primary sedimentation tank. So, what is primary sedimentation tank? They are designed to remove a part of the organic matter from the sewage effluent coming out of the grid chambers. So, as I have already told before that since we already have seen that primary preliminary treatment, we have seen that grid chambers, we have talked about screens, we have talked about grid chambers, we have talked about the shredding devices, and we have talked about skimming tanks. So, those are there, but then it is completely dependent on you on what you choose for your treatment plant. So, but most of the time we use grid chambers and most of the time we use screens. Okay. So, after the grid chambers we generally remove we will usually put the sedimentation tank. So, what happened is that in the grid chambers, I have already told, we have already discussed before, grid chambers is going to remove the inorganic material, inorganic part of the inorganic the inorganic material from the wastewater. But in primary treatment, we are in primary sedimentation tank, they are going to remove the organic part. Okay. So, the inorganic matter is removed by grid chambers. So, they are designed to remove a part of the organic matter. Now, it is only a part of the organic matter, not the whole organic matter, right, because we obviously want to remove all the organic matter, but that is not possible. So, sedimentation tank is going to remove only a part of the organic matter. They are generally done in either rectangular or circular tanks. Okay. So, the detention period is around 1 to 2 hours, which is actually very high, right, as compared to grid chambers, which we used to have only some in minutes, 2-3 minutes. These are the overflow rates. Okay. The overflow rates for generally plain sedimentation is around 40,000 to 50,000 liters per meter square per day. For sedimentation tank with coagulants, we have 50,000 to 60,000 liters per meter square per day, and for secondary sedimentation tanks we have 25,000 to 35,000 liters per meter square per day, right. So, as I think you have already talked about sedimentation tank in water treatment. So, the principle behind it is similar. So, water treatment and sedimentation, it's all you are sedimentating you are actually what you are doing in sedimentation tank, you are holding all the water or the wastewater for a period of for a period of the detention period, and holding it and keeping it so that all the settleable materials is going to settle down, and afterwards you are going to you are allowing the effluent to leave. So, whatever will be left, the sludge is going to be removed. Okay. So, this is a circular sedimentation tank here. See here, so you have, so you are holding, see you have many circular sedimentation tanks here generally, right. So, here, so generally this looks like this. What will happen is you are going to, the flow is going to come through here, it is going to flow out, and this is the inlet, right. Then what will happen is this is it's going to be allowed to sit in the sediment in the wastewater in the sedimentation tank for the detention period, which may be around 2 hours, and then the sludge is going to get settled down, right. The sludge, whatever is settled down, is going to be removed through this part, right. This is the scraper. So, this is how a sedimentation tank works. Sludge should be removed before from the sedimentation tank before anaerobic conditions develops, because if anaerobic conditions develops, then we may have other huge problems, like it may start giving very bad smells, foul smells, right. So, as sedimentation tanks is almost very similar to the water, the principle is same, but here what you are using is wastewater. So, obviously, the sludge amount is going to be huge. In wastewater tank, in water tanks, that amount is going to be, whatever is settled is going to be lesser, here is going to be more, right. So, now coming through again for sedimentation tank, as I have already told here, in plain sedimentation tank, we generally remove around 60 to 65 of the suspended solids and 30 to 35% of the BOD. So, we are not able to remove 100% of everything, we are able to remove a huge part of the suspended solids. Why? Because it is suspended. So, obviously, if you keep it for a particular time, then it is going to settle down, and 30 to 35% of the BOD, which is a good amount, right. The organic matter is slightly heavier than the water and settles slowly in the range of 1 to 2.5 meter per hour, right. For inorganic, which was in the case of grid chambers, the settling was much more. Why? Because density was higher, right. But here the organic matter is only slightly higher than water, is around maybe 1 plus something, the specific density, right. So, then there is another concept called short circuiting here. Okay. So, what is this concept? Sometimes in a sedimentation tank, the flow is not uniformly distributed throughout the cross section of the tank, causing a substantial portion of the water to pass directly through the tank without being detained for the intended detention period. In such case, the flow is said to be short circuited, right. So, what I am meaning to say here is that, say for example, you have a sedimentation tank here, right, and you want the water to stay here. If you put the water here to, for example, 2 hours. So, if we talked about a particular particle of water, right, you want this to stay for, but sometimes what happens is that this may come and just flow off without staying for this particular 2 hours. May say for example, this goes out here at a period of around say 1.2 hours, let us just say it. Okay. Then whatever happening, this is not able to, so that is called short circuiting. So, let us read again. In a sedimentation tank, the flow is not uniformly distributed, right. Some may stay for a longer time duration than 2 hours, and some may stay for a lesser time throughout the cross section of the tank, causing substantial portion of the water to pass directly through the tank without being detained for the intended detention period. In such case, the flow is said to be short circuited. To avoid short circuiting, so once you have short circuiting, what you are going to do? Here is not, the settling is going to be lesser. So, your sedimentation tank is not going to serve its purpose. So, what do you do in these cases? In these cases, what you do is, to avoid short circuiting tendencies and hence to distribute the flow evenly, the inlets and the outlets of a sedimentation tank should be properly designed. So, you have to design your inlets and outlets very properly, so that short circuiting short circuiting is going to happen, always happen, but then the ratio of whatever is short circuited should be very less. Then you will have a very good, well designed sedimentation tank. Short circuiting is something which you cannot, it is going to happen, but then you may reduce that amount, right. At the same time, so then coagulants like ferric chloride, ferric sulphate, alum chlorinated copperas are sometimes added to wastewater for sedimentation added with coagulations. So, here we have talked about primary sedimentation tanks, right. Here this sedimentation we have talked about, say we can have either plain sedimentation, in which you do not add any type of chemicals, right, or else you can add some chemicals like coagulants like ferric chloride, ferric sulphate, right, which will act as coagulants. But in most cases we do not use sedimentation with coagulation for wastewater treatment. We do not use, most of the time we do not use this. Okay? Why? Because if you add this chemicals, because your wastewater after going through primary treatment is going to go through secondary treatment. Secondary treatment is mostly biological. So, if you add this chemical, they are going to hamper your secondary treatment system. So, if you go for trickling plants, trickling filters, this if you the effluent from the second sedimentation with coagulation tanks, right, may have a very bad effect on the trickling filters. You do not want that. So, most of the time we simply go for plain sedimentation, and we do not go for sedimentation with coagulation for wastewater treatment. Sometimes they may go, that is completely dependent on you, but in most cases we do not do it. Now, let us try to solve this problem on settling tanks. Okay. So, here it is actually very easy. In settling tank, what you have to remember for sedimentation tank is, you have to remember this detention period and this overflow rates or surface loading. This overflow rates are also called surface loading. Okay. Right. So, what you have to remember from your exam point of view, you have to remember this detention period and this, right, because in your exams this may not be given, and you may be said ki you can assume all your values, right. So, that assumption has to be nearer, so you have to remember it. So, what is the problem here? Design a circular settling tank unit for a primary treatment of sewage at 12 million liters per day. Assume suitable values. So, you are supposed to assume suitable values, right. So, if you do not have an idea of what is a detention period, you will not be able to assume suitably. Presuming trickling filters are to follow sedimentation tank. Since you are presuming that trickling filters are to follow sedimentation tank, what will happen? You are not going to do sedimentation with coagulation, you are going to do plain sedimentation, right, and surface loading. So, what you are supposed to do? You are supposed to you are simply given this value of 12 milliliters per day, and you are supposed to design a settling tank. You are supposed to assume detention period and surface loading. Okay. So, let us start our problem with an assumption. So, what we will do? Assumption, detention period you can assume for 1 to 2 hours. Here what we are assuming? Let us assume that detention period is for 2 hours, right. Then let us also assume that the surface loading is 40,000 liters per meter per square, right. Why? Because if you remember it, we have talked about plain sedimentation. In plain sedimentation, the overflow was 40 to 50 liters per meter square per day, right, here. So, here. So, here we have assumed 40,000 liters per meter square per day, hence, right. So, what will happen? Hence, quantity of sewage treated in 2 hours. So, detention period is for 2 hours. You are going to hold that water for 2 hours. So, if the surface loading is 40,000 liters per meter per square, right. So, what you are saying here, that the sewage is 12 million liters per day. Agar if it is 12 liters per day, million liters per day, then in 2 hours how much it will be? 12 into 2 by 24, right, 24 hours per day. So, 1 million liter per day. So, that means 1000 meter cube, right. So, your sewage treatment, the quantity of sewage treatment in 2 hours is going to be 1000. That is what it means, that the capacity of the tank should be 1000 meter cube, right. Now, what you have known here, you know ki your tank is going to be for 1000 meter cube, right. Others you have to design. Now, what is the surface loading? Surface loading is Q divided by the surface area of the tank. So, you are supposed to design a circular tank here, right. So, Q by surface area of the tank, Q and surface area tank will be what? Pi by 4 d square, right. You are going to design this d, right here. So, what is Q here? Q is 12 million liters per day, 12 million liters per day, right. Then surface loading, what you have assumed? You have assumed surface loading of 40,000, 40,000, right, pi by 4 d square. You are going supposed to find out d square. D square if you d if you worked out, it will be 19.6 meter, right. So, this is the diameter. So, you had a capacity is 1000 meter per square, the diameter is 19.6 meter. Now, you have to what you have to find out? You have to find out this depth, right. So, effective depth of a tank is what? Capacity by the area of cross section. So, the capacity here divided by the area of this, right. So, obviously, 1000 divided by pi by 4 into 9.2, right, which works out to be 3.2 meter, right. So, what you have designed here? So, what you are designing is 3.2 meters. So, plus always give a free board of 0.3 meter. Let us give a free board of 0.3 meters or 0.5 whatever free board. So, what you have designed here? You have designed, so the settling tank you have designed is for 19.6 meter dia and 3.2 plus 0.3 meter depth, right. Right. So, this is a problem. Now, this is was primary treatment. Primary treatment, I am not concentrating much on primary treatment, because primary treatment is generally sedimentation tank, and sedimentation tank you have talked a lot about in water treatment. Now, let us come to the secondary treatment, which is actually very important, the most important part of wastewater treatment. Secondary treatment is it's huge, and there are many parts of secondary treatment which we are going to talk. Before we talked about we go to the various parts of secondary treatment. Let us talk what is secondary treatment. Okay, first secondary treatment. Once the effluent comes out of the primary treatment, right, that is the sedimentation tank, the effluent from the primary treatment still contains around 40 to 50% of the original suspended solids, right, and virtually all the original dissolved and dissolved organics and inorganics, right. So, whatever the plain sedimentation, the sedimentation tank and the grid chambers, they are able to remove some part, but then still there is many things which is not removed from the wastewater. The wastewater is actually right now very polluted, and you cannot discharge that to the river, right. And what are you going to do? So, to meet the discharge standards, the organic fraction of both suspended and dissolved solid must be significantly reduced, right. So, inorganic was already removed by grid chambers, primary sedimentation removed a part of the organics, right, but majority of the organic part is still there. So, what you have to do is you have to remove the organic fraction of both the suspended and the dissolved solids, right. This organic removal is referred to as secondary treatment, and may consist of chemical physical processes or biological processes. So, secondary treatment is after the plain sedimentation, right. They are supposed to remove all the organic fraction, most of the organic fraction, okay, and it consists of either chemical or physical processes or biological processes. Okay. So, this chemical physical processes may be coagulations, microscreenings, filtrations, chemical oxidations, carbon absorptions, etc. There are many things by which we can do it, but we do not generally use it. Okay. Why? Because it is extremely costly, and it's not we don't generally use, we require many things for that. The most easiest way of doing secondary treatment is through biological processes by microorganisms. It is very affordable and very good also. Whatever is left will be, can be used as fertilizers, many things, like whatever after the sludge after the biological treatment can be used as fertilizers, can be done, but whatever is after the physical chemical process may create more problems for us. So, when you talked about secondary treatment, we will be concentrating majorly on the biological processes and not on the physical chemical physico-chemical processes. Like, so I just wrote it because I thought you should know that there are secondary treatment can also be done through physico-chemical processes, but we will not be discussing more on it, and we will be discussing only the biological part, which is actually right now very much in use and very good. So, so this is actually the secondary treatment. So, the secondary treatment part, right, so can be through either through, as I told you, physico-chemical or biological, right. Physico-chemical means you can use physical or chemical, you can use some chemicals like coagulants, or you can use through physical processes like filtration and all those things, which is going to be very costly, and a country like India cannot afford it. Okay. When you talked about biological, it can be of two types, either aerobic or anaerobic, right. Everyone knows this. Biologically you can have two ways, aerobic and anaerobic. What will be aerobic? Aerobic will be in the presence of oxygen, right, and anaerobic, what will happen? Without oxygen. Right. So, secondary treatment either physical chemical or biological. Physico chemical you will forget it, we are not discussing. Biological, when you talked about biological, either it may be aerobic or anaerobic. If you go for aerobic, it means that it is happening in the presence of oxygen. So, what will happen? So, when you talked about aerobic, we generally require some type of aeration. Okay, aeration in the sense what? You require oxygen, you require aeration, right. So, you will have some amount of oxygen. Then anaerobic, aerobic, this is without oxygen, you know, you don't require, you don't want oxygen. So, obviously no oxygen. In aerobic there may be two terms, we will be discussing it later on. One is called aerobic attached culture, another is called aerobic suspended. In aerobic attached cultures, what is happening? The filter materials, to say aerobic attached culture are like trickling filters, contact beds and RBC. What you have to remember about aerobic attached culture is it is attached. The bacteria, the microorganism is attached to your filter. So, if this is the filter, if this my hand is the filter, your bacteria is going to be attached to it, right. So, in a trickling filter what will happen? You have this filter materials and those bacteria will be sticking to it. So, that is the attached, it is attached. What you have to remember about this is attached, right, it is attached. Whereas, in aerobic suspended, the bacteria is suspended, it is free flowing, it is not attached to anything, it is flowing, as in it is everywhere, it can move around. Okay. Whereas, in attached, it is attached, fixed. So, aerobic suspended in the sense it can be activated sludge and oxidation ponds or aerated lagoons. So, what these are all, there may be more, I have just written the major parts. Okay. In activated sludge what will happen? It is a tank with the waste water and the bacteria, which is the bacteria is free flowing, it can move everywhere it wants, right. Even in oxidation ponds, right, the bacteria are there, it is free flowing, it is not attached, there is no media. whereas in attached we have medias, right. Whereas then in anaerobic we have other anaerobic facilities like anaerobic facultative and stabilization ponds. Then we have septic tank, it is a sort of a sedimentation tank, but then it is an anaerobic system. Imhoff tank, right now not in use. Then we have other high rate anaerobic system which is actually very in. Here you will talk about very important things like UASB, which is called upflow and sludge blanket, right. Very important, very in right now, new technology, right. So, after this the next part we will be discussing in my next lecture. Thanks a lot for hearing to me, and I hope you have a very great day. Thank you.